This lesson will focus on quantitative sampling methods, specifically sample size. So now that we know how to actually sample for quantitative studies, the question becomes, what is a good sample size? How many individuals is enough? How many might be too many? It is probably clear to you that for most situations, one person is probably not sufficient. And at the same time, billions of people is probably an unrealistic goal in terms of time and money for actually completing a study. So there must be some sort of middle ground between 1 and billions to find what actually it is that we would need for our study. There are two basic factors, or two sets of considerations that we can use to understand what is required to have a good sample size. The first set are scientific considerations. Three factors that most scientists should consider when determining the sample size is first the willingness to make an error. This is the classic alpha level that if any of you were in psychology or sociology classes on research, you heard about. This is typically it's set at 0.05, and the idea is that how often are you willing to make an error in your research? Traditionally, the idea is that 5% of the time you're willing to make an error, so that 95% of the time you would be correct, or at least the sample that you found, if any findings occur, there's findings that you could feel confident in 95% of the time. The second factor is the expected effect size of the independent variable. The expected effect size of the independent variable can be thought of as how big of an effect would we expect the independent variable to have. So for instance, if the independent variable is, does our new antidepressant medication have an effect on depression? If we expect it to have an enormous effect on depression, meaning it would cure it in most cases, then we would probably need a smaller sample size to show that. Whereas if it was a very minuscule effect, the drug would have an effect on individuals who have depression, but not a huge one. Then we would probably need a lot more people to demonstrate that. And then the third factor that is a scientific consideration is the power of the test. The power of the test is a complex concept. The fancy definition is written here, and it is the long-term probability of rejecting the null hypothesis given the effect size, alpha, and the number in the population studied. Practically, you can just think of the power of the test as how likely is this statistical test to determine, to accurately determine whether there is an actual, whatever the results of the study are accurate. Generally, power of the test is most often looked at by the number of people in the study. And the basic rule of thumb is that the more people in your study, the better the power of the test. Some more scientific considerations to consider is, of course, having too small a sample. If it's too small of a sample, then it will be difficult to detect any meaningful effect in the variables, even if those effects are actually there. At the same time, it is possible to actually have too large of a sample. Enormous samples that have 15,000 or 20,000 people, you will find statistically significant effects for almost insignificant differences. So for instance, there might be a statistically significant difference, but the the practical reality is that it doesn't really matter. The effect of whatever your independent variable is minor. Determining the best sample size is called a power analysis, from what we discussed in the previous slide about the term power. Entire books are written solely on this topic and entire research articles. If you're curious at all, there's an article that should be available to you through the library for free by Cohen, and it's a good source if you're very interested. Cohen is sort of the guru of power analysis, and if you're really interested, you can read his many books on this topic. There are also, in addition to the scientific considerations, practical considerations. One is pretty obvious, and that is money. Money is required to either pay participants or to pay researchers to help you collect participants, and so as a result, you need a lot of money often to get a lot of participants. Another practical consideration, or really limitation, is time. And with time, often a lot of researchers are under time pressure to either publish for grants or for their own job security, and so as a result, it's difficult to just sit back and let a study go. Time also plays a role in terms of being a threat to the validity of a study, in that if a study takes too long to collect the data, say if it takes you 10 years to collect data, so many things might have happened between those participants who were collected in the first year and those participants who were collected in the 10th year that the results of the study might not be totally valid anymore for all participants anymore. Finally, a practical consideration is the importance of the research. By importance, I have it in quotation marks because theoretically all research is important, but it's safe to say that people who are doing, or at least in my mind, it makes sense that people who are looking at research that is actually going to help people who are dealing with acute deadly illnesses, perhaps that's maybe more important, or at least more timely than research which is looking at things that are not as life-threatening. So for instance, there's a period of time in the 80s when HIV and AIDS were considered the utmost importance. They're still important now today, of course, but there was a real drive to find a cure and a way to help people who had HIV back in the 80s. As a result, many studies did not require quite as many people for drugs as other studies normally would have, because the research is considered to be more important. So in sum, you can see that there are practical considerations, scientific considerations, and that both must be balanced appropriately by the researcher in order to adequately create a sizable sample. With all this said, a good sample size tends, for the purposes of counseling research, tends to be, again, around 150 or more, 150 to 300 people, depending on what you're looking at.